Hello, this is the video on adding and subtracting rational expressions. You should take a minute to copy down the steps into your notebook. So I'll give the steps in the header there. So go ahead and pause the video, copy down the steps, and resume when you're ready to see the examples. All right, let's go ahead and chat. So at the beginning of this unit, we talked about basically all of the rules that we have for adding and subtracting fractions with numbers. Is going to be the same for adding and subtracting rational expressions. So, for example, when you have 1/2 plus 1/4, you need a common denominator to be able to add those. So what we do is we multiply this by 2, and that by 2, and then this one can stay, and that gives us 3/4. Okay, so we're going to do the exact same thing here with rational expressions. So this first example here, you know what I see? I see common denominators because I see x minus 2 and x minus 2. Oh, that's so lucky. Because that means we don't have to find a common denominator. Instead, we can just carry over the denominator and we can add the top. So 3x plus x. And then simplify. If we look at 3x plus x, well, the number hiding in front of this x is ninja 1. So 3x plus 1x gives us 4x over x minus 2. Now, looking at this x is multiplying and this x is adding, so I can't cancel them. So this is about as simplified as it's going to get. Okay? Nice and easy. Okay. Let's take a look at the second example. And the second example, we have some pretty gnarly denominators there. But actually, when you look at that, they're exactly the same. 3x squared minus x minus 2, 3x squared minus x minus 2. Whew! So again, we don't have to find a common denominator. We can carry over the denominator, 3x squared minus x minus 2, and then we can add the top. So 7x plus 5 plus 4x, minus 4x plus 3. Okay? Now be careful that you want to put minus 4x plus 3 here in parentheses so that you know you're not just subtracting the 4x, but you're also subtracting the 3. So let's go ahead and simplify. 7x minus 4x gives me 3x. 5 minus 3 gives me 2. And we can go ahead and copy over that denominator. Now, in this case, we might want to factor this bottom to see if we can get a common factor with the top and cancel some things out. So I'm going to go ahead and use the box method here. And the ways to get to 3x are 3x and 1x. And I need to find something that multiplies to negative 2 and adds to negative 1x. So I think I will put 2 here and 1 here. And I will make the 1 negative because that gives me negative 3x plus 2x, which gives me negative 1x. So then I can rewrite this 3x plus 2 over 1x minus 1 times 3x plus 2. And when you look at that, I have a common factor in the top and the bottom. So this just turns into 1 over 1x minus 1. Okay? Okay, these two examples were nice because we had common denominators. Now, these examples are not going to be so nice, okay? If you look at this one, the denominators are different, right? We have 6x and we have 2x squared. So we need to find a common denominator for both of those fractions. Well, number-wise, I know I'm going to have to multiply this one by 3. So I'm going to say by 3, by 3. Now over here, now that would give me 9 over 6x squared, which is close, but this is just 6x. So to make this one match, I need to multiply this by x, which would give me 5x over 6x squared. Okay, now I have a common denominator. That will give me 5x plus 9 over 6x squared. Remember, just carry over the denominator. And looking at this, there's really nothing I can simplify, right? There's no greatest common factor here, and nothing's going to cancel there. So let's kind of recap that one real quick. I didn't have common denominators. So what I did was, okay, what can I do number-wise to make this one look like this one? Okay, I multiplied by 3. And then this one had a higher degree, right? It was x squared, so I knew I had to multiply this by 1 more x. So you're really just trying to get it into the same bottom here. And remember, whatever you do to the denominator, you have to do the numerator. So keep that in mind. Okay, let's do another problem like that. This next one's really similar. We have 7y to the 4th and 3y squared. Well, we already have 4 and 2 that are kind of a problem here, right? This y to the 4th and y squared. So we know that's going to be a problem. And the 7 and 3 are not the same either. So let's deal with the numbers first. For 7 and 3, that greatest common denominator is definitely going to be 21, right? They don't have anything in common. They're both prime. Now, for y, well, this one's bigger. And y squared goes into y to the 4th. So we know our greatest common denominator is going to be y to the 4th. So now let's figure out what we have to multiply each fraction by. This one is almost the same except for the 7. So this one we just have to multiply by 3. Okay, that would give me 9 over 21y to the 4th. Now this one we have to multiply by 7 and y squared to get y to the 4th. Okay, so 7 to get 21, y squared times y squared to get y to the 4th. Now doing that out would give me 14y squared. Okay. Now we have common denominators, we can go ahead and add. So 9 plus 14y squared, those are not like terms, so I can just write 14y squared plus 9, or you can keep it the other way, over 21y to the 4th. Now looking at this for simplification, 14 and 9 don't share any common factors, and there's no variable. Same thing here. So I'm going to go ahead and say that's the simplest it can be. Excellent. Okay, let's try a little bit of a harder problem. This one is a little bit more difficult because if you look at bottoms, it's not immediately obvious what we are going to do for our common denominator there. And they don't really have, like I can't really multiply d minus 1 to get d plus 2 in any way, right? So sometimes when you can't find a common denominator, you just multiply them, right? Think about if we had a problem that was like 1/5 plus 1/6, right? The greatest common denominator for both of those is just going to be 30, because 30 is 5 times 6. That's the only thing that they have in common. So this time we're just going to have to multiply d minus 1 times d plus 2, and on the top as well. This one we're going to have to multiply d plus 1 to the top and the bottom. Now, you might need to do a box for this. So we'd have d plus 2, d minus 1 would give us d squared, 2d minus 1d minus 2. So I'm going to go ahead and simplify that since those are like terms. Our common denominator is going to be d squared plus d minus 2. And when I multiply the top, I can just think about the distributive property, would give me 3d plus 6. Okay? Now, if I do d plus 2, or d plus 2 times d plus 1, or d minus 1, my bad, or d minus 1 times d plus 2, it doesn't matter if I do them one way or the other, I'm still going to get the same answer. But now here, I have to distribute over here. So this would be 2d minus 2. Now I can go ahead and do that subtraction. So 3d minus 2d gives me 1d. 6 minus negative 2, minus the negative turns into addition, over d squared plus d minus 2. Now looking at this, no greatest common factor in the top. Okay, I know the factors of d squared plus d minus 2 are d minus 1 and d plus 2, right? That's how I found it. So I also know from that that nothing's going to cancel because neither of these are the same as 1d plus 8. So this is the most simplified form of this one. Okay, let me recap that example for you real quick. This cannot find a common denominator like we would find for one of these, right, where we just have to multiply by pieces. This we just have to multiply by the other denominator. So we multiply this side by d plus 2 over d plus 2. We multiply this side by d minus 1 times over d minus 1. Okay, that got us these, and then we subtracted them. Let's see that one more time. In this problem as well, we have common denominators that aren't going to have a least common multiple other than just their product. So to get our common denominator, we're just going to have to multiply them. So I'm going to have to multiply c minus 2 and c minus 2. I'm going to have to multiply 3c minus 1 and 3c minus 1. Okay? I'm going to go ahead and do my box over here. So I have c minus 2, 3c minus 1, 3c squared minus 6c minus 1c plus 2. Okay, these are common, are like terms. So my underneath is going to be 3z squared minus 7z plus 2. On the top, I have to distribute that c, so I'm going to get c squared minus 2c minus, it's going to be the same thing on the bottom over here, because it really doesn't matter what order I multiply them. But on the top, I'm going to get 12c minus 4. Okay? Alrighty, let's go ahead and do that subtraction. So 3c squared minus 7c plus 2 as our denominator. C squared, no like term, so that one's just going to come over. Negative 2c minus 12c is going to give us negative 14c. And then minus negative 4 is going to give us a plus 4. Okay? Now, we could try and factor these out. But we know the factors of 3c squared minus 7c plus 2 are 3c minus 1 and c minus 2 from over here. If you look at c squared minus 14c plus 4, what would I multiply to 4 and get to negative 14? There's really nothing, right? This would be way too small to get negative 14c, and we have nothing up here to work with. So this is about as simplified as it's going to get for this problem.